Hi, so I'm hoping today's video is going to be a little bit shorter. I'm not working on the sheet music program today. I have a couple of things to do, so I don't think I really have the time to get into it. But there is a small project I've been wanting to do for a while, which is something to deal with permutations and permutation groups. So this video is going to be making a simple C++ program to multiply permutations. Okay, so let's do that. The technique I'm using to multiply permutations is something I found in The Art of Computer Programming. I hope I have enough of it in my head so that I don't have to reference the book too much, because you won't be able to see that on the screen. So we'll start with the usual libraries. The amount of times I've typed this, I may as well just make it a template. Well, whatever. I think I explained this in the last video, but endel is actually kind of slow, and it's actually more characters than just el, which is what I call this function. And this is what you do instead of endel. Okay. It's pretty minor, don't worry about it. Oh, sorry, let me make the text a bit bigger. Okay. So first, there are two ways we could do this. One of them is to use the Lexer generator, which could be fun and probably a little bit better than what I'm planning to do, but I'm not really familiar with how to use flex or lex or whatever. So maybe we'll do it later if this goes well. So I'll make two test strings here for myself. I don't know if I want to use a string library or not, but sure, why not? So let's have this permute, I don't know, 1, 3, 4, and 8, 5, 4, and then maybe 1, 2 to try and keep it interesting. Oh yeah, interesting. So we actually need two algorithms here. I don't know what the project's going to be. I'll write it as a void function for now. We need one. No, you know what? I'll make it a string. Yes, I could make these fancy objects. We can do that later. For now, I just want to get the algorithm in place, and then we can move it after the fact. Okay, so we need one that multiplies permutations. That seems pretty obvious, but actually we also need one that reduces permutations. So this permutation here is not reduced. You see there's this, well, maybe it is reduced. Hold on. It's hard for me to tell. Okay, well, you know, we'll just ask Gap to do it. I always get the syntax wrong in Gap. It's kind of horrific. Okay, well, I know it's not reduced. I just want Gap to reduce it, so I wish I knew how to use Gap better. Well, actually, hold on. Maybe I can just do this. And I can just use the star operator. Oh yeah, okay, perfect. Yeah, okay. So there we go. That's the permutation. 138542. That's kind of interesting. That I could just delete it like that. Well, whatever. I'm gonna worry about that later. Then here, let's just do, I don't know, 2, 3, 4, 5. Okay, so the algorithm we're gonna do is pretty simple. I think the easiest way to explain it is probably just by drawing it out. And having a drawing will make it easier to write the code anyway. So the idea is, okay, look, first let's write out the two permutations that we have. Now this is a really clever algorithm. I really like it because it actually uses the parentheses in a really neat way. Okay. So the idea is we're going to scan this from right to left. And all the while, we're going to keep track of the final location of each element. Oh, actually, interesting. The output of you'll see what I mean. Okay, so let's write down each element. And so let me try and make this a little bit nicer. Okay. At the beginning of the algorithm, how do I explain this? These numbers here, I'm almost tempted to make them red. They're just there for reference. They're just there to help us see what's going on. They're not part of anything. I just made a copy of them over here. In fact, I am going to make them red. It'll be too confusing, I think, if I don't. That didn't really work, but whatever, you get the point. Okay, so the idea is, as I scan from right to left, I update where I update this table here. So this is my memory that I'm using. This is how do I put this? This is my input. It's much harder to explain this than I expected. Okay, that's my input, and this is a vector that we're keeping in memory. That's going to get updated as we iterate backwards through here. Okay. All right. Hopefully that makes sense. So what I'm going to do for an iteration is I'm going to copy this so you can see what the value was on the last iteration. Yeah. Okay. I think this will work. Let me just space these out a little bit more. Okay. Maybe I should copy paste it actually. So we get to the first, or I guess the last number in the input. And so far nothing happens, but on the next one something's going to happen. Because here, oh wait a minute. Oh yeah, I remember how this works. This is really surprising. Okay. At the first iteration, nothing happens. We just, I guess, initialize it to this iota vector. Then, when we step forward, we go to the location pointed at by the number, and replace it with the character that comes right after it. You'll see it, it'll make sense. So we have this kind of thing going on. Okay. Now we do the same thing. On this one, we go to this index and replace it with this character. So this looks kind of dumb, doesn't it? Well, whatever, it works. Alright, and then basically that's the algorithm. I'm going to keep going until I get to this first parenthesis, and I think you'll get the idea. So now we go over here and we do the same thing. We go to the third index right here and replace it with this number, with the 4. Actually, if I'm clever. Oh yeah, that's much easier. Okay. So it's a pretty simple algorithm, but it works really well. It's really cool. Alright, once again, we go to this index, number 2, and we replace it with this number, number 3. And now here's the clever bit of the algorithm. We come to the left parenthesis character. Oh, I lost my right parenthesis character over here. Whatever. There. Okay, and then, oh yeah, okay, see, this is why we draw it out, because what I forgot is when you replace a member in this vector with the right parenthesis character, you have to save what it replaced in a temporary variable. So we saved a value of 5, and now the idea is when we get to the left parenthesis, oh, I just noticed something. When I was supposed to, from this step to that step, copy the whole thing and make the change, but I accidentally pasted an earlier one that still had a 5 here. Oh wait, no, wait a minute, no, that's what I was supposed to do. Something is weird. Oh wait, what am I doing? Again, it's like I say, drawing out the algorithm really helps you understand it. No, obviously I don't use the 5. I use the 2. I just keep doing the same algorithm. Right? The only difference is that now... Hold on. The only difference is that now I can't use this character to index the table. What I do is I go and find the right bracket. So actually I don't even really need to save anything over here on this end. Although for efficiency, I may store the index of where the right bracket is so I don't have to search for it. But now the idea is I go to this index, quote unquote, which is here, and replace it with the next character as usual. Okay, well, that's cool. So let's do that. Okay, so over here, we've done the first cycle in the permutation, and as you can see, it did actually apply the permutation 2, 3, 4, 5 to this, I guess, identity permutation. The 2 went to 3. Is that right? Wait, no. This is weird. I think I did it wrong. Maybe this video won't be so short after all. 2 had to go to 3. Yeah, maybe you do have to save this 5. Hmm. Well, okay, let's think about it. We don't go to this index and replace with this number. Actually, what this permutation is telling us is that this number, or whatever's in this location, I should say, is going to go where this number is telling us to go. So I did it backwards. Okay, so let's quickly do it. We'll get there, don't worry. Okay, so this is the initial, and this doesn't make sense. All right, well, I tried. I'm gonna open up the book now. I should have looked at it before starting the video. But then again, you know, I don't even know who these videos are for except for me. So. Can't find the damn thing. Okay, so I have the book in front of me here. Yeah, I think what I just said was right. Yeah, we go to this location and put that character. That's what I did first, isn't it? Wait. Hold on. We go to this location and put that character. Do I not understand what permutations mean? Well, this kind of mistake and fixing it is all part of the process, so let's keep going. Oh, okay, I see the problem. This is the correct algorithm. This is telling us that 2 goes to 3, 3 goes to 4, 4 goes to 5, and 5 goes to 2. Right? 2 goes to 3. You see, I wasn't interpreting this correctly. This vector does not tell us what this initial vector does under the permutation. This vector tells us, it's like a table, it's like a lookup table. Given an index, where do I go? So 2 goes to 3, 3 goes to 4, 4 goes to 5, and 5 goes to 2. So now we come to this reduction function, which I shouldn't really call a reduce function anymore, but actually it's going to take in, you know, this vector events. It's going to take in this vector and reduce it to something written in cycle notation like this. And the algorithm to do that is also relatively simple, but I've done it before and it's kind of tricky. I had to do it for another program, not for permutation multiplication. I just can't remember which program I did it for, otherwise I might be tempted to copy the code. But okay, I think we have enough to get started here. We have to decide something. Here my numbering starts at 1, and we were saying go to index 4. Well, 1, 2, 3, 4, but in a computer we have 0 indexing. So do I want my permutations to have zeros, or do I want to do that conversion on the fly? And then there's another thing, right, which is I'm forcing myself to use integers here. What if I wanted to use arbitrary variables? Okay, here's an idea. We can have a map from a string. That's not how you do that. From a string to an int. And this is going to be our name map. Because there's another problem that I haven't said out loud yet, but I've been thinking about, which is here the biggest number is 8. But actually there are only 1, 2, 3, 4, 5, 6 unique numbers here. So I could, for example, change this to a 6, and then I wouldn't actually need to store these, well, technically, because I used an 8 instead of a 6, notice how this 6 and 7 didn't do anything. I didn't even have to have them, right? So that's memory I didn't need to use. In this example, it doesn't matter, but if, you know, somebody had written instead, you know, something like that, then I would have way too much memory for no reason. So the idea here is that we can make this more general and nicer if we simply pick out all the different strings. We treat these as strings, not integers. The strings between the commas and parentheses. And we give each one a separate int. So then we can do nice things. We can put A and B and C and stuff like that. Okay, so let's put it back the way it was. And we also have another problem, which is kind of annoying, is that we do need to distinguish between integers and parentheses. So one easy way to do that is to give the codes of -1 for parentheses. I think that's suitable. I think that's fine. Right? Well, we can go with that for now. It should be pretty easy to change anyway. Okay. So the first thing that we want to do is fill in this map. So no, not const. And we'll give it the two permutations in question. But while we do that, we may actually want to return a pair of because we have to convert all these strings to an int in this function anyway, right? But we also want to convert these permutations from strings to the vector of integers. We may as well do it here. It'll be a lot more efficient. So here we're going to have that looks kind of horrific. Maybe I can do this. Okay. C++17, I think, has a nice way to return multiple values. But I don't even know what version of the compiler I have here, so... Alright, let's go with this. So, we want to read in strings delimited by commas and parentheses. So I know how to do this in C, but if we're using C++, we may as well do it the C++ way. I don't like that. That's ugly. I can't believe there's no good way to do this in C++. That's ridiculous. Yeah, this is the way to do it in C. Nah, I don't like this. Oh, this might be nice. I never used boost, actually. You know what? I'm just going to use string to k. I just realized for the first time, this is string tokenize. In my head, I've always thought of this as string to k. Okay, well, let's get to work. That's going to be the technique here. I'm just wondering if I should make a copy of the text, because string to k modifies the string. Well, let's do the copy. It's easy enough to take out later. Is that something you have in the string class? Oh yeah, I had forgot I have to include that. Good. Yeah. Yeah, C string. Yeah. Wait a minute, it was a const. I don't want a const. Maybe I can use... Yeah, maybe I can use this. Does it have a null character? It might not. Okay, I'm just going to comment this out because I want to try it, and that's not going to compile. Or it'll throw a warning, maybe. I don't know. Okay, so then let's do... I did this without thinking. Again, I typed this so often, I should make it a template. It's not the most efficient, but when you're pretty printing, you don't normally care about efficiency anyway. Okay, and actually, I'm going to make this unsigned, and hopefully the conversion will happen properly. there's no null terminator on it. But actually, that's easy enough to fix though, because then we just do okay, I think that's what we'll do. Does that make sense? Does that make sense? Yeah, I think that's okay. Kind of think of it. Well, no, you know what? This is fine. This is fine. Well, if we don't want the compiler to complain. All of this is so we can use string decay. Okay. Let's see if this goes through. No return statement, that's fine. I was just checking to see if it complained about the types. Okay, and then, no, I always forget the nice way to do this. There's probably an example on that page. There's a way to do this that doesn't have complicated loops. Oh yeah, like this. Yeah. I hope no one can hear me talking. It would really bother them. It's kind of early-ish on Sunday morning. Okay, and then what we're gonna do is we're gonna do shoot. Let me think. Let me think. Okay. I'm usually a bit paranoid about RVO. Okay. So now we'll do perm1 first. Turns out string decay might not have been easier because of all this extra work I had to do. By the way, I don't think I need to explain this, but I'm using vectors because it takes care of memory for me. Okay. And we also need the null terminator. Okay, so this is the return. I'm sort of jumping around here, but it's all going to come together. So now I need to check what map returns. understand this first one. Do I not understand how mapped works? Yeah, we have this. Oh, I see. Oh yeah, okay, you have to have a pair of key type, map type. Okay. Okay. I didn't realize that, actually. Okay, fine. I don't know what to call this. This might fail because token is not a string object, it's just a char pointer. But maybe it'll work. Which integer to use here? What else do we have? Yeah, that should be it. Still going to need. Wait, I don't need that, do I? I don't really care if it was already in there before, but I do need okay, I think this should be okay if I do this. I can just do oh yes, that's why I needed to do that. I forgot about that, so this is an iterator, so I think I have to do this. Man, I need to know what this iterator type points to. To the key. So if I do this, yes, temp arrow first, yeah. So let's just do this. Auto map number a better idea. I have a better idea. This is a neat trick I saw in a video somewhere. Check this out. I think this works. Maybe not. Whoops. Are you really gonna make me do this? I can't do it like that, it'll make it an int. I've been foiled. I thought this would be nicer, but it really isn't. Oh man, it really doesn't like that. Oh yeah, actually, I think we might be okay. Where's the error? No match for operator equals. Oh, it has to be a tuple, doesn't it? No, I thought I could get away with it. But tie doesn't really work, does it? Yeah. Oh, I see. Yeah, I had to use the iterator, not the value type. But now we should be in business. Yes. Right. Okay. Oh yeah, I just do it arrow second. That's pretty good, right? Yeah, look at that. I can live with that. These warnings are bothering me. You always got to be careful when you copy and paste code. That's probably fine. Okay, no worries, but do you think it's gonna work? there's no way it's going to work right. Okay, let's ignore the return value for now. And let's make a helper function here to print out maps. Interesting. It's pretty much going to be the exact same thing. Except here, I want to do this. I want to do this. Alright, well, cross your fingers. See if I got it. Alright, it compiles. Yeah. Is that right? 0, 1, 2, 3, 4, 5. Yeah. Huh, look at that. It made the first ID 0, it made C, the second ID 1, H, the third ID 2, E 3, D 4, B 5, and that's all of them. It didn't overwrite it or anything. Okay, now let's check the return value. Oh, I've shot myself in the foot. Because I need the parentheses, don't I? Maybe I don't. If I assume that if for this multiplication function, I assume, yeah, let's do that. Oh, wait, no. Yeah, I do need the parentheses, don't I? Okay, let's do that next, but first let's see if what I have so far works. Yes, 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 and yes. Okay. That's not too bad, actually. That's a bit long. I guess it's okay. But yeah, we need to deal with the parentheses. Okay, there's a cheeky thing we could do. is getting messier by the minute. I don't like this. I don't like this. How long have I been at this? An hour. Wow. Okay, here's a new idea. This may be making my life complicated, but okay, so the idea here is let's say that this is the permutation that we want to store. I shouldn't have done that actually. I need that. If this is the permutation we want to store, we'll store it as and then 0, 1, 2, 3, 4, 5, 6. That's the idea. That is the idea, and that should be okay. Okay, I think I like this. No, that's in memory. So unfortunately, C++ will automatically default construct these. There's no way to get around it. C doesn't do it, and sometimes it's a bad thing, but in this case it's a good thing because I don't need these initialized. But anyway. Okay, this is okay. Yeah, I'm okay with this. It's still a little bit horrific. See, this will compile. Oh boy. Okay, first. Huh, actually. Will this work? Oh boy. Oh boy. Insert. Arrow. Yeah. Arrow. No seg faults. Oh, seg faults. Yeah, I thought so. I always forget how to do this. I wanted to yeah, I think I need make shared for this. think it could figure it out? I doubt it. No, of course not. I can do this. I can do this. I love C++, but sometimes it can be really dumb. Okay, so far that looks good. Now what I want to do this is going to be pretty slick, I promise. Maybe it won't be so slick. Yeah. Again, pre-printing doesn't have to be efficient. So we can do this actually. There's a reason to do this. Oh, iterators would be a lot better. Nah, that's fine. We'll just do this. Will that work? Yeah, this damn warning here for comparison between. So annoying. This is weirder though. Oh yeah, data. The more this goes on, the more ridiculous it gets. All right, what do you think about that? Put that in your pipe and smoke it. So it didn't work. Darn. I don't want to do this in the debugger, it's going to be awful. Maybe I can just look at it and figure out what the problem is. Okay, that's correct. That is not. Wait, is that correct? Oh yeah, of course that's correct. Okay, so the second permutation doesn't have its cycles number being set. So let's go check that out. Aha. Gotcha. That should not be there. We're pretty good. Yes, that is correct. Of course, we would like to do a reverse lookup. Actually, maps aren't so good for that, are they? Oh, you can't search by value. Yeah. Well, I don't need this anymore. Let's do the comment. So the idea here is that I actually want to do like a, a name lookup here, kind of an idea. So this seems kind of dumb, but we can invert the map and index it. I think that's what I want to do. a linear search would be better than inverting if we were only looking up one name. But since we might be looking up quite a few names, it's better to do this inversion, I think. Will it even compile? No, of course not. Of course not. What, really? Oh, yeah. I always forget that it's a shared pointer. Still doesn't compile. Ooh, we're getting there. Yeah. Hey, we are golden. So it's been well over an hour and we've written the input routines. But actually this is kind of nice though, because we have, you know, a good struct with nice methods and stuff like that, which are going to make our life easier in the future. So I'm actually okay with this. Now, what time is it? 10 a.m. I don't have time to continue, which is a shame because I really wanted to get to the permutation today. Okay, well, I guess I'll do that next time. Okay, well, I guess that's enough for one day.